Hi everyone. As you continue working with Power BI, you realize that visualizations are very easy to work on, given that you have the data in the format that you want. And we learn to appreciate that Excel is so much better because Excel makes it so easy because it's a sandbox. You can copy and paste values as you wish. You do not have to create relationships. You can use dollar signs to write very effective formulas. Power BI, on the other hand, makes things a little more difficult because you have to be very systematic in your approach. And that's a good thing in the long run because it forces you to be systematic. And in Excel, the challenge is that you might get the result after a lot of running here and there, but then you're not really creating a process that is repeatable and efficient. That is the good part about Power BI. Now, one question I get asked all the time is the difference between DAX and M. DAX being data analysis expressions that we use in Power Pivot and data models, and M being Power Query functional language that we are using. And even within DAX, we have two different things. So we have the calculated column and we have the measure. So in this example, I want you to look at all the three, and I'll get very deep into the differences, the advantages and disadvantages between all the three. The file is also available on GitHub with the solved examples in it, in case you want to download and have a look at it. So the data set that I have here is very simple. We have a data called fact_sales. It's a transactional data with 51,290 records in it. We have the order date, the shipping date, the customer name, city, state, country, region, market, category, segment, subcategory, sales quantity, discount, and profit. Now, let's build a problem statement. Let us say that using my sales and my discount, I would like to know the net sales. This being the gross sales, I would like to know the net sales. Now, one way to do that would be to go to table tools and then select new column. So first we have to come to the data view, then we select table tools and then new column. Since these discount numbers are not readable, they're not percentages, let me also change the format here and make this into a percentage. So that's better. You can see that we have varying levels of discount that is being offered here, right? So we have 0, 10, 60, and so on. So we go to table tools and we select new column. And in the new column, I'm going to first give a name to the new column that we are creating. So we will call it net sales. And then we say that the net sales is nothing but my sales value multiplied by 1 minus the discount value. We press enter, and as you can see, when the discount is 0%, of course, we get the same result in net sales as well. But if I scroll down, and let's come to a discount value being a little higher. Okay, so you can see here that on a gross sales of 1,888, I'm offering a discount of 30%. So my net sales is 1,321. So this is great. We have the net sales amount. And if I go back to the data visualization view, I would like to create a card and keep the net sales amount in it. You will also notice that the net sales has a different icon on it. And the reason is that it is a calculated column, right? It is not something coming from the source data. So on the net sales, we want to look at maybe the average. So it tells me that the average net sales is 220.24. Now imagine that you do not want to create this new column and then find the average. So we could have also written a measure. So we can go to new measure. We will first give it a name. In fact, first let me call the other one net sales CC. So we know that this is a calculated column. And here we can go to new measure and we will call it net sales measure. And we want to find the average X, the table being my fact sales table, and the expression being what we had written earlier. That would be my sales multiplied by 1 minus the discount, like this. Let's first check the result. So we'll copy and paste this. And I will replace my calculated column with the measure. And you notice we get the same result. And here, if you look at the icon, again, it's different. So we have this icon for the calculated column, and we have a calculator symbol for the measure that we have calculated. Let us also do the same thing in Power Query. So I go to transform data. We will scroll to the right, add column, custom column. I will call it the net sales, and that would be my sales value multiplied by 1 minus discount. Close and apply. Copy and paste. In fact, we should call it the net sales PQ so that we know this is Power Query. So we just call it M, and we'll come back. And it has to be a number as well. So let me go back to transform data and change my net sales into a decimal number as well. Close and apply. And change it to the average. And as you can see, we get the same result. Now the question is, why are there 3 different ways of doing it, and how do you decide which one should you be using? So this is the link that I would like everyone to go through on SQL BI, which tells you the difference between calculated column and measure. Now I'm not going to read the entire thing for you. The link is there in the video description as well, but I would strongly urge you all to read it. But I'll just broadly tell you what all has been explained here. Now, calculated columns can be created not just on Power BI, because DAX is available on Power Pivot for Excel, on SQL Server Analysis Services, and on Power BI Desktop. The way we create a new column is a little different in Excel and in Power BI. In Power BI, we give the name in the formula bar, but in Excel, if you notice, we don't give the name in the formula bar. All of these things have been explained here. Now it says that the calculated column is just like any other column in a table, and I can use it wherever we want. And the problem here is that all calculated columns occupy space in the memory and are computed during the table processing. Now this might be the most important point to keep in mind, because what happens is that if you have a very large data, and if you're not even using that calculated column too many times, it probably makes sense to create a measure, because a measure means that it is not occupying RAM on your system, and the computation will only happen when you use it, not when the data is being loaded in the first place. And the difference here is between the compute time, the process time and the query time. So the idea here is that when you're creating very complex calculated column and you're not really looking at RAM here, you're looking more at the process. That means the amount of time it takes for you to create that calculation. It might make sense to opt for a calculated column because you're not really concerned if the query is a little slower, but you are more concerned about the user experience. Also, when it comes to intermediate columns, it is considered to be a bad habit in production because each intermediate calculation is stored in RAM and it wastes precious space. So it makes sense to not have 5 calculations to arrive at a result if you can combine all of them into a single calculated column. When we talk about measures, those of you who have been working on Excel for a while would remember that we had an option called calculated field before when you used to work with a pivot table. Of course, now it has become a measure. And this is the part which is important. So if I want to compute the aggregate value, then I cannot rely on calculated columns, right? For example, if I go back to my report and I go to the data view and I want to find the profit margin. Now I can't do profit divided by sales. Think about it. Because I don't want to find the profit margin for each individual transaction and then average it out. The profit margin for the company would be the total profit. That means the sum of profit divided by the sum of sales. That would be the correct way to go about it. Which means that if I create a new column and I say that my new column is profit margin, which is equal to the profit divided by my net sales, this will not give you an error in the sense that it will work. You will get the result. And let me convert this into a percentage as well. But I hope you see why this is not the correct way of going about it, because a business will not find the profit margin for each individual transaction and then find the average from that. The correct way would be to find the sum of profit divided by the sum of sales. So let me delete it. We'll go back. And here I want to create a new measure, which will be my profit margin, that is equal to divide the sum of my profit, comma, the sum of my sales amount. Let's make a card and keep the profit margin here. And as you can see, we get 11.61%. Now, this would not have been possible if you had worked with a calculated column. So this is one of those cases where you have to use an aggregation. So it has to be a measure that you use. Okay, let me just quickly tell you what else is important in this article. So the measure needs to be defined in a table, but it does not belong to any table, which means you can move it from one table to another table without losing the functionality. So while they look very similar, the calculated column and the measure, remember the value of a calculated column is computed during the refresh and it uses the current row as context. It does not depend on the user interaction. So when you're creating more dynamic models and you have external filters and slicers and connectivity with other charts, you can't really control all of that because it does not depend on user interaction. But a measure does. In a measure, by using all selected, you are able to control the way the calculation will get affected due to the user interaction with other elements on the report. Now, why would you want to use a calculated column? If you would like to see it in a slicer, then you don't have a choice. You have to use a calculated column, because if I try to make a slicer and I keep the profit margin in it, that doesn't work, right? So for example, if I try to keep my net sales calculated column in the slicer, you notice it works. But if I try to keep my net sales measure, right, which is this one, that doesn't work. So when we're doing the calculated column, it works. When I do the net sales M, which is what we wrote in Power Query, that works as well, as you can see. But the moment I try to do this for the measure, it doesn't work. So the simple answer is that if you want to use it in a measure, then you have to create either a calculated column or do it in Power Query. Let me just go back to transform data. I accidentally deleted my new column, so let me recreate it. So net sales, and we have M, which is my sales multiplied by 1 minus my discount value. We have to convert this into a number as well. So let's do that. And perfect. There you go. Let's come back to the article. Also, if you want to define an expression that is bound by the current row, then of course you have to use a calculated column. And of course, if you want to categorize text or numbers, that will not be possible if you create a measure, because a measure will only give you one value. It won't give you a column as a result. And when do you use a measure? Whenever you want to display the resulting calculation value that reflect the user selection. So when you're interacting with other elements on the dashboard, then you have to use a measure. And the advantage here is it does not consume memory and disk space, because the measure will only come into play when you are using it inside a visual. Otherwise, it does not waste RAM storing any intermediate calculations. Then the article also tells you how you can avoid intermediate calculation by using SumX. Like the example I did showed you an average X. So this one explains to you with the SumX. And it also says that using Power Query is also an idea, because Power Query also will not use a lot of space compared to using calculated columns. So while you might all think that what I'm trying to tell you is not to ever use a calculated column, as you saw, there are some very clear advantages of doing that. One more advantage of using a calculated column is that if you want to, for some reason, export this data to an Excel file, then I can simply click on the three dots and select copy table and then paste it in Excel. Now, this would not have been possible if you had created a measure, because the measure will give you the results that you want. So I am able to see the average, which is 220.24, but then I can't export it in my Excel file. So that's another reason why you might want to choose a calculated column. My final takeaway is that if you're working with smaller data sets, it hardly matters which one you use. It's a matter of choice. But then it's important to understand the differences between them. And as you mature and you're using more DAX and you're interacting with different elements on your dashboard, you will start to see that calculated columns will not really help you that way, because calculated columns are always permanent. But if you want to interact with your measures in a slightly different way, then you have to use DAX in a measure, not in a calculated column. So be curious, try different things. Don't just read one article. Go online and read like a dozen articles that will help you understand fundamentally what the differences are and help you make a better choice.